Space. A void. The sheer absence of matter creating a vacuum due to a very, 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 very low pressure environment. So we're told. However, we're also told that NASA successfully landed 12 men on the moon because its spacecrafts and spacesuits were able to withstand such a low pressure environment. Hello again, this is Paul on the Plane. Welcome to episode 3 here in our third season of Faking Space and our continuing analysis of the photos, videos, and information given to us by the world space agencies, showing conclusively their stories just don't add up. In this episode, Mr. Scott Henderson and I will explore what we're told by NASA about the lack of air pressure in so-called space, and analyze whether its own equipment, such as the Apollo lunar module and the astronauts' spacesuits, would actually survive. Mr. Henderson has invested more than 10,000 hours into researching the claims made by NASA as it relates to the Apollo program. So let's see if you come to the same conclusions we have. Let's start by covering a real-life example of the power of a vacuum due to one air pressure system being reduced adjacent to another air pressure system to kind of set the context here. The classic example, at least in my mind, is a railroad tanker car. You can search for and find many examples online of the structural integrity of a tanker car failing when the air pressure inside is reduced, which eventually subjects the walls of the tanker car to levels of pressure it cannot withstand on the outside of the tank, and it implodes in a thrilling fashion.
Well, there it was.
Some tanker cars are made of aluminum, some are made of steel, and they fail rather dramatically when the air pressure inside is reduced to a point where the air pressure inside the tank is not strong enough to withhold the force of the air pressure pushing against the outside of the tank. The key to grasping this is understanding what I refer to as back pressure, or the lack thereof. Let me illustrate further. In an episode of the popular science show, Mythbusters, Adam and Jamie collapsed a steel train tanker car by lowering the air pressure inside the tank down to 3.4 pounds per square inch, or psi, meaning they had increased the outside pressure pushing against the walls of the tanker to 11.3 psi, which equates to about 1,600 pounds per square foot of external pressure over the entire outside of the tank. Now, those numbers are derived from the fact that at sea level, we experience approximately 14.7 psi. So before some of the air was vacuumed out of the tanker car, there was approximately 14.7 psi pushing on both the inside and the outside of the tank. But as the air pressure was reduced inside to 3.4 psi, about a 75% vacuum, that meant there was a difference, or negative pressure as some call it, of 11.3 pounds per square inch, which equates to more than 8 tons per square meter crushing into the tank externally on all sides, and it simply could not withstand it. And bam! Did you know that 14.7 psi equates to approximately 10 tons of force for every square meter? But, you may ask, how do we survive as humans with such a force applied externally to our bodies in all directions? Well, it's simple. There's 14.7 psi of back pressure too, a perfect state of equilibrium. And this is the important point. Now, let's go to so-called space and apply these concepts that are observable, testable, repeatable here on Earth. When we talk in terms of space, the most common scale used is torr, and it's expressed as 10 to a negative number, meaning there are a bunch of zeros after the decimal point before you get to the numbers. At sea level, 14.7 psi equates to 760 torr. And if you could achieve a perfect vacuum, which is not attainable, 100% vacuum, it would be considered 0 psi. Now bear with me here, as it's important to understand the conversion from psi to torr, and then back again to put it in terms that we are accustomed to, in order to fully understand how strong the negative pressure would be in space. That again is if space exists as we are told it is. To crush the tanker car, the air pressure was reduced from 760 torr to 176 torr. That is 14.7 psi down to 3.4 psi inside the tank. The Kármán line, as it is called, is considered to be the boundary into outer space from Earth, and it exists at approximately 62 miles or 100 kilometers above the surface of the Earth. At this altitude, we are told the air pressure is 10 to the negative 3 torr. That equals just 0.000002 psi. Up to the Kármán line, the environment there is classified as a quote-unquote low vacuum. So, if we were in a capsule of sorts at 62 miles above the surface of the Earth, we are told that the air pressure being applied to the outside of the capsule is down to just 0.000002 psi. But the pressure inside the capsule, if we took off from sea level, like most rockets do, would again be 10 tons per square meter. How do you think the capsule we are in would be able to withstand 10 tons of pressure per square meter on the inside of the capsule walls trying to get out with just 0.000002 psi of back pressure? Do you see where I'm going with this? And this is only at 62 miles above the Earth. From 10 to the negative 3 torr to 10 to the negative 9 torr is classified as a quote-unquote high vacuum. And the scale is not linear, it's exponential or even logarithmic. The largest and most powerful vacuum chamber in the world is located at NASA's Glenn Research Center in Sandusky, Ohio. According to NASA, their massive vacuum chamber has the capability to reduce the air pressure down to 10 to the negative 6 torr, which is 1,000 times stronger of a vacuum than 10 to the minus 3 torr at the Kármán line. And it takes many hours to pump the air out to get down to 10 to the negative 6 torr, and the facility has 6 to 8 foot concrete walls reinforced with a leak-proof steel containment barrier built in so that the concrete dust and no air can be sucked through the walls and into the chamber itself and ruin the vacuum they are trying to create. If you were able to reduce the air pressure further inside a chamber, then you are getting into the quote-unquote ultra-high vacuum classification. This is 10 to the negative 9 torr and above, which is approaching the level of vacuum we are told exists on the surface of the moon, which is an astonishing 10 to the negative 11 torr, which is the numbers 100 million times stronger of a vacuum than the Kármán line. Now, those numbers were given, but perhaps those are just estimates, since we've never been there and can't simulate that here on Earth. Some interesting notes about the Glenn Research Facility, which we are told is able to simulate 10 to the minus 6 torr, still 100,000 times weaker than the surface of the moon, was built in 1969, the same year Apollo 11 allegedly achieved putting 2 men on the surface of the moon. But if you really dig to find out when the world's largest vacuum chamber was first opened, you'll find out it was actually in October 1969, 3 months after Neil and Buzz allegedly walked on the moon. And even then, we are told the vacuum on the surface of the moon is 100,000 times stronger than what even NASA's best vacuum chamber could achieve. Once you reach even the quote-unquote high vacuum classification, this is what we are told the Glenn Research Facility can achieve, 10 to the negative 6 torr. You need vacuum seals like these, on the left, which are metal and comprised of one-time use materials. They are needed to seal in a high vacuum area. On the right are the helmets seals of the Apollo missions. The latch fits in the groove for easy installation. The connection does not have the capability to compress the seal and logically would not function even in a low vacuum. The gloves of the spacesuits have a similar type for an easy connection. The surface of the seals must also be virtually perfectly clean and free of foreign materials for the seal to even be effective, or it will fail under such a low-pressure environment. The Apollo astronauts using the same suits covered in dirt for 3 EVAs, it would be impossible for the suits to work and reseal multiple times. The same is true for the hatch for the lunar module, as they had to crawl through, dragging dust and dirt with them. The door seals would not be functional. The LEM could not be pressurized after re-entry. In this image here on the left are examples of seals used to, again, contain a vacuum. On the right is Neil Armstrong's glove. The connection that holds the glove to the suit are just like a door latch that pushes out into a channel. They do not compress the seal between the metal. This design is for an easier way of putting the suit on and off during practice, and of course, simulations. This connection, however, would not even hold a small amount of pressure. The fact that the LEM did not have an airlock means that any container within the craft had to be designed to withstand the vacuum of space, which we are told again was 10 to the negative 11 torr. This is a complete error in simulation, NASA. The food pouches would explode as the aircraft depressurized, as well as the urine bags and feces in the jettison bag. Any other containers within the craft for air or for water would be subjected to the vacuum of space and would suffer the same consequences, and probably pretty dramatically. Here is a typical NASA fanboy or fangirl explanation, however, of why the ultra-high vacuum of space isn't a big deal. That when you walk out into space in your spacesuit, it will want to expand. But how strong is that pressure? It's only 1 atmosphere, so not that strong. They're specifically designed to keep the suit from ballooning out. And that, folks, is where the deception lies. This is the type of statement that NASA gives when describing the vacuum of space. NASA tells us that the air pressure on the surface of the moon is 10 to the negative 11 torr, however. And this equates to nearly negative 2 billion psi, because there is almost no back pressure at all. Not the 14 psi you will see in the comments of many videos on this subject. Do the conversion yourself, people. 10 to the negative 11 torr equates to negative pressure of 131 million atmospheres. To further illustrate this point, I corresponded with a company who specializes in vacuum lifting after seeing one of their promo videos. The representative who emailed me back stated that they can achieve 25 tons of lift by creating roughly an 80% vacuum, 165 torr, between their lifting pads and the massive pipe here as an example. That is nearly the level of vacuum achieved that collapses train tanker cars. That negative pressure uses the fact that the air outside of the pipe, especially underneath it, is pushing or pulling so hard in an attempt to get into the little space between the lifter and the pipe that it can achieve 25 tons of lift. Are you starting to understand the amount of force that the inside of the spacesuits and spacecrafts that NASA built would have to withstand to maintain integrity? One final point. Have you heard of the Apollo rock box? It's an aluminum case that the rock samples the Apollo astronauts collected on the moon were stored in for the trip home and to be opened here on Earth. We are told that the lunar atmosphere was preserved inside this aluminum box. Again, 10 to the negative 11 torr. I guess these rock boxes are stronger than steel tanker cars and stronger than the Glenn Research Facility walls by hundreds of thousands of times. And if you think the lunar module, made of a few layers of aluminum, is stronger than the Glenn Research Center vacuum chamber, and if you think the Apollo spacesuits remain flexible at 10 to the negative 11 torr and is stronger than this building, 100,000 times stronger it would have to be, then you've been successfully indoctrinated. The only thing NASA has sent to space, people, is your imagination. On behalf of Scott Henderson, this has been Paul on the Plane. Thanks for watching.
We can do this, and we need to do this because this is it. This is it, okay? This is it. There are probably lots of other nice planets out there that we're going to find, but they're going to be really far away and out of reach. We can't even go to the moon, for God's sake. This is it. So let's deal with this one first before we start thinking we can go running off somewhere else.